What up, geometry students? We're talking about equations of lines. Equations of lines are all possible x, y points that are going to still have the same slope, no matter where that location is. So, like, as long as we go from 1, 3 to this point x, y, and as long as my rise over my run smushed together is 2, we have a line. Well, we start with like the slope formula, how you can like take this y minus 3, and that's like the change in y, and this x plus 1, and that's the change in x. And as long as y minus 3 over x plus 1 equals 2, we win. Or we can go straight to what's called the point slope version of a line, which is after multiplying by x plus 1, we say, what are the y's and the x's that work in this equation? This is the equation of a line that has all xy points that are connected with the point -1, 3 that have a slope 2. And this allows us to use an equation to find missing points instead of maybe like trying to figure it out. It just becomes like an easier process to do. When x is 4, what must be y? Well, 4 plus 1 is 5 times 2 is 10. And then y minus 3 equals 10. Y has to equal 13. Done. So the point 4, 13 connected with the point -1, 3 will have a slope 2. What about the point x, -9? Well, y minus 3 equals 2 times, I should probably write the equation down right now, 2 times x plus 1. When x is x and when y is -9. So I'll replace that y with -9. I'll replace x with nothing. I'm going to have to find x. Solve an equation. I get -12 equals, I'm going to distribute the 2. I could divide both sides by 2 right now if I wanted to. But if you distribute correctly. Subtract 2, divide by 2, and you get x is -7. So the point, -7, -9, if replacing this xy, will connect with the point -1, 3 and have a slope 2. What if we have a y coordinate of 0? So I'm going to replace the y coordinate with 0 in my equation for all possible xy's that connect with -1, 3 to have slope 2. And I get 0 minus 3 equals 2x plus 2 after distributing. And I'm subtracting the 2 and dividing by the 2, and I get x equals -5 halves, or -2.5. And same thing with 0y. I will replace x with 0, and I will find y. So I have 2 times 0 plus 1. That's -3 equals 2x. Y minus 3 equals 2. Y equals 5. Don't forget that the y is still there, like I just did. All right, so now we just have a way of finding all possible xy's that connect with a specific point 4, 2, and when it connects, we will have a certain slope. You can find the change in the y's, that y distance, by doing like the y value minus the other y value, so y minus 2. The change in the x's are x minus 4. You could also see this using the equation of slope. And after we've done this enough, we realize that we can use this point slope form of an equation, y minus y1 equals m times x minus x1. We want to find all possible xy's that connect with the point 4, 2 to have a slope of 2/3. All possible xy's must satisfy this equation. Y minus 2 divided by x minus 4 equals 2/3, or y minus 2 equals 2/3 times x minus 4. Done. This would be the equation of all possible xy's connecting with the point 4, 2 that would have a slope of 2/3. Same here, we got xy connecting with -2, -3, and when we connect, we should have a slope of 4. Y plus 3 is I usually like to write it so that the -2, -3 is on top of xy. What is the y change? Well, I would say it's y plus 3. What is the x change? I would say it's x plus 2. So either understanding the slope formula that y plus 3 over x plus 2 has to equal 4, or going straight to your equation y plus 3 equals 4 times x plus 2. I don't expect you to do this process of writing it in terms of like y minus y1 over x minus x1 equals m. You can go straight to the y minus y1 equals m times x minus x1. But now that we have this, we can find any point on the line. Let's say I want to find a y coordinate of a point that has an x coordinate of -2 for this previous line. I'll just make sure you understand which one's an x and which one's a y. I don't know the y. I know the x is -2, so I'll replace -2 for x, and I'll be able to find this other location. I have y minus 2 equals 2/3 times -6. -6 times 2 divided by 3, or -6 divided by 3 times 2, or whatever you want to do to get that this is -4. And you have y minus 2 equals -4. Add 2, don't make a mistake here. You have y equals -2. So -2, -2 actually connects with the point 4, 2. What if the x, what is the x value when the y coordinate is 13 for the equation y plus 3 equals 4 times x plus 2? Well, I have the y coordinate of 13. I will replace y with 13. I will not replace x. I'll have 16 equals 4x plus 8. I will subtract the 8. I will divide by 4, and I'll get x equals 2. So 2 comma 13 connects with the point -2, -3, and has a slope, a y's per x, of 4. It's a different way to think about lines than maybe you did in geometry. Okay, now we're going to be asked to do a little bit more, find a specific point called the x-intercept and the y-intercept. What's very, very important is that the x-intercept is when we hit the x-axis. When we hit the x-axis, we have to have a y-coordinate of 0. So an x-intercept is the x-coordinate when y is 0, or I'm finding the point x0 like I did in the previous questions. The y-intercept is when our line crosses the y-axis. The key thing is that the x-coordinate has to be 0. So I start with a slope of 1/3 and a point 2,4. I want all xy's that connect with 2,4 that have a slope of 1/3, and all the xy's must follow this equation of y minus 4 equals 1/3 x minus 2. And again, it really follows the equation y minus 4 over x minus 2 equals 1/3, which is a slope formula. Or if I go from 4 to xy, this distance from 4 to y is y minus 4. This distance from 2 to x is x minus 2. And y's over x's, boom, slope. So now I want to find the x-intercept when y is 0. I get -4 equals -1/3 x minus 2. Now this is a great example when I'm finding the x-intercept of, we don't have to distribute always. You see this see this 1/3 here? I would love to not have to distribute that to the 2 and then deal with fractions. Well, since it's 1/3 times x minus 2, I can decide to multiply the right side by 3 and the left side by 3. And when I do that, I get -12 equals just x minus 2. Think about the multiplication of 1/3 times something times 3. I'm allowed to multiply the 1/3 and the 3 first, even if the something is like a parentheses and has pluses in it. So a lot of people think they have to distribute the 3 everywhere, but in reality, since it's multiplication of 3 different things, I can multiply the 1/3 and the 3 first, and then leave the x minus 2, which allows me to find this x value without having to work in fraction land. Adding 2 to -12, I get the x-coordinate of -10. And for the y-intercept, That is when x is 0, I'll have y minus 4 equals 1/3 times 0 minus 2. I do have to work with fractions. I mean, I could actually. I don't have to. I could get rid of this 1/3 again. Y minus 4 equals 1/3 0 minus 2. I could multiply everything by 3. However, this is not in parentheses. So if I do multiply the left side by 3, it would be 3y minus 12. So maybe just be careful. Let's work with fractions. Let's be okay with negative 2/3 and adding 4 to negative 2/3. 4 to negative 2/3. I'm going to turn 4 into an amount of thirds. That will be 12 thirds. So combining 12 thirds and negative 2/3, I get 10 thirds. Okay. The next equation of the line is all of our possible xy points that connect with the point negative 4, 3, but have a slope of negative 3. Well, that means the y change of y minus 3 divided by the x change of x plus 4 has to equal negative 3. Or if we want to write it all in one nice line without any fractions, we would say y minus 3 equals negative 3 times x plus 4. So again, it's y minus 3 over x plus 4 has to equal negative 3. Find the xy points that work. And multiplying by x plus 4, we get this equation of a line. This is really an equation of a line too. Y minus 3 over x plus 4 equals negative 3 is actually an equation of a line. Like, I'm just going to show you really quickly, if you're paying attention, that if you go into Desmos and you type in y minus 3 divided by, you're going to have to maybe use parentheses or like highlight y minus 3 and then divide the entire y minus 3 by x plus 4. Set that equal to negative 3. You get a line. So like this is the equation of a line. It's just typically in math classes, we like to write it all in one level instead of using a fraction. But it's pretty cool to see that y minus 3 over x plus 4 equals negative 3 is a line. It's all of the xy points that when connected to 3, negative 4 has a slope of negative 3. All right, but I digress. Let's keep going. Some of you just want the answers. I respect that. When we are finding the x-intercept, y is 0. Many different ways to solve this equation. Here's something I'm going to do. I'm going to divide both sides by negative 1. Now, since this is multiplied, we're allowed to do that. You don't have to divide the x plus 4 by negative 1, by negative 3. Sorry, did I say negative 1? I meant divide both sides by negative 3. So that you get 1 equals x plus 4. You don't have to divide the x plus 4 by negative 3 because you already just did the negative 3 divided by negative 3. Cool? And then you subtract the 4 and you get x equals, look at that, another negative 3. So we would like to write the x-intercept as negative 3 comma 0. The y-intercept is when x is 0, so I have y minus 3 equals negative 3x, which is 0 plus 4, so 0 plus 4. And I have y minus 3 equals negative 12. I have y equals negative 9, so 0, negative 9. Let's see, I mean, I graphed on Desmos y minus 3 and x plus 4, and there's negative 3, 0, my x-intercept, and there's 0, negative 9, my y-intercept. Great. The next questions, I give you 2 points. But you can see that I'm looking for all of the xy points that will follow the slope that connects and extends these 2 points from 5, 2 to 2, negative 1. Well, we got 5, 2, we got 2, negative 1. I probably want to start with the 2, negative 1 on the top. We should find the slope between these 2 points. We should find the rise over the run so that we can stay consistent. Well, I can see that the y's, we are adding 3, and the x's, we are adding 3. If you went the other way around, you'd say subtract 3, which means the slope of this line is 1. So that means there's any point that connects with either of these points, as long as it has a slope of 1, it's a point that wins. So we could start with the idea of the point 2, -1 going to the point xy having a slope of 1, or you could say the point 5, 2 connecting with a point xy has to have a slope of 1. And that's not right. Don't want to confuse you here. So the point 2, -1 connecting with xy, well, the y change will be y plus 1. The x change will be x minus 2. So y plus 1 over x minus 2 has to equal 1. Or y plus 1 has to equal 1 times x minus 2. Now let's say we connected with the point 5, 2. It's still fine if you connect with the point 5, 2, these xy points that have to have a slope of 1. We'll have an x minus 5 and a y minus 2 change. So that means y minus 2 over x minus 5 also has to equal 1. You could have put y minus 2 equals 1 times x minus 5, because you'll find that both equations will give us all of these possible points, these xy's, that connected with either of those points will have a slope of 1. It's very good to potentially see this, whether you type it in this version, or you type in the other version, y plus 1 equals 1 times x minus 2. This is what I'm typing into Desmos. And I'm also typing y minus 2 equals 1 times x minus 5. We see that it's the same line. Because again, we already know how those 2 points are connected with a slope of 1. So if I go from one point, the other point will be included, or vice versa. So the x-intercept or the y-intercept, doesn't matter which equation you use, you could find them. X-intercept is when y is 0. Maybe I'll use the one equation of the x plus 1 equals 1 times x minus 2. So I'll have 0 plus 1 equals 1 times x minus 2. This is easy enough to just distribute the 1, add the 2, and I get x equals 3. Maybe I'll do the y-intercept with the other equation. Do you have to? No, it doesn't matter. It doesn't matter. Doesn't matter if you are just copying down and not actually listening to what I'm saying. Y-intercept is when x is 0, so I have y minus 2 equals 1 times 0 minus 5. Y minus 2 will equal -5. Y will equal add 2, -3. So 0, -3. All right, so those points on the x axis are at 3, 0, and 0, -3. Okay, another one like that. Maybe I'll just go quicker. Morning. We're going from 5 to 3. That's a change of -2 for the y's. We're going from 1 to 6. That's a change of +5 for the x's. Make sure you put your y's over your x's. As long as your xy connected to either point has a slope of -2, 5, you will have a winning xy. So we have, let's use the point 1, 5. I just like to use 1. Y minus 5 equals -2/5 is the slope, x minus 1. And you could have had y minus 5 over x. Again, we're looking for the xy points. Y minus 5 is the change of y's. X minus 1 is the change in x, as long as that slope is -2/5. This is the equation of a line, honestly. This is also an equation of a line. You know, that's something I'll bring up in class today, which is cool. If you graph in Desmos y minus 5 divided by x minus 1, you set that equal to -2/5, you get the equation of the line that contains the points 1, 5. It contains the point. Oh, look at that. It doesn't contain the point 1, 5. And that's why. Oh, that's fascinating. Okay, cool. So not going to get into it. It says it's like 1 undefined. It's because you're not allowed to divide by 1, which is why we multiply by the 1. And now we have the 0.15 to get a 0 equals 0 besides like divided by 0. I'm sorry, I'm digressing. If you want to know why we can't see the 0.15 on this first equation, let me know. If you don't worry about it. But that's the reason why we come over here to this y minus 5 equals negative 2/5 x minus 1. The x-intercept y is 0. Negative 5 equals negative 2/5 x minus 1. Ooh, I do not want to distribute the negative 2/5. But you know what I could do? Multiply everything by 5. Now, on the left side, I get negative 25. And if I multiply the 5 by the negative 2/5 times the x minus 1, I'm just going to get negative 2 x minus 1. That's going to be easier to work with. Just as a algebraic technique, you should always check to make sure you're doing it correctly. I'm going to subtract the 2 to get negative 27 equals negative 2x. I'm going to divide by 2 to get x equals 13.5. So the x-intercept is 13.5, comma 0. Y-intercept when x is 0. Y minus 5 equals negative 2/5, 0 minus 1. I have to take positive 2/5 after multiplying negative 2/5 by negative 1 and add 5. 5 is 25/5. So I have 25/5 plus 2/5, which is 27/5. So x is 0, y is 27/5, which is 5 and 2/5, so 5.4 if you have a calculator. Let's look at our graph, make sure. Here is our x-intercept at 13.50. Here's our y-intercept as 0, 5.4. Beautiful. All right, a couple challenges, 3 challenges. Where you just got to pay attention to things. Remember about perpendicular slopes and parallel slopes. Line F has a slope of 4 and passes through the point 1,4. Here's the equation for line F. Y minus 4 equals 4, x minus 1. Find the equation of line G. Line G is perpendicular to the line F. And it passes through the point 1,4. Oh, that's easy. This is easy. So we know that the slope of F is 4, which means the slope of G has to be negative 1/4. Opposite reciprocals. If you have 4 over 1, flip it to negative 1 over 4. We have x minus 1. We'll have y minus 4 because they share the point. That's it. That's G. That's not much of a challenge. Who said that? I did. I made this homework. All right, let's see if the next question is a little bit tricky. Line A has a slope of negative 2 and passes through the point 5, 2. So y minus 2 equals negative 2, x minus 5. This is line A. B is perpendicular to A, so I know the slope of B has to be a half because the slope of A is negative 2. But it passes through the y-intercept of line A. So line A has a y-intercept when x is 0, so I need to find the y-intercept of A by plugging in 0 for x to see what is the point that works. I'll get y minus 2 equals negative 2 times negative 5, which is positive 10. I will then add the 2 to get y equals 12. So we have the point 0, 12, which means the equation of B will use that point 0, 12. I'll have y minus 12 equals 1/2 x minus 0. Fine with me. And I'm going to use Desmos to check. It's always nice. So let's see. We have the equation of y minus 2 equals negative 2 x minus 5. We see the y-intercept is at 0, 12, which means a perpendicular line y minus 12 equals 1/2 x minus 0. Well, bam. There's that perpendicular line. And going through this y-intercept. So the answer with y minus 12 equals 1/2 x minus 0. And the last question. Line D has a slope of negative 1/2 and passes through the point negative 4, 3. So that means y minus 3 equals negative a half x plus 4 would be an equation of all possible xy's that, when connected with negative 4, 3, have a slope of negative a half. Ooh, sorry. I meant to say line C has the slope of negative a half that passes through the point negative 4, 3. And then I want you to find the equation of D. I apologize for the wording of this question. Line D is perpendicular to line C, so its slope's got to be 2. It passes through the x-intercept of line C. Line C has an x-intercept when y is 0. So I have negative 3 equals negative a half x plus 4. Going to divide, multiply both sides by negative 2 to get positive 6 equals x plus 4. I'm going to subtract 4 to get x is 2. So I have a x-intercept at 2, 0. And now I have the equation of line D. Just double check that if you like. You got line C perpendicular to line D, both having the same x-intercept. It's a good challenging question. Just graphing these on Desmos to double check. And seeing that they are perpendicular and they both share this x-intercept of 2, 0. All right, that's it. Peace.